Have you ever been playing a game and wondered if the AI that runs a virtual city could actually solve, say, real-world traffic jams? Well, that's exactly what we're talking about today, how the tech behind our favorite games is being used to simulate and maybe even shape our own reality. Okay, let's get into it. You know that feeling, right? You're in some huge open-world game and the city just feels alive. The characters, the NPCs, they have their own routines. Cars actually follow traffic laws most of the time, and crowds totally react when you cause a little chaos. Well, that intelligence, it's way more than just smoke and mirrors for entertainment. And that's the big leap. What happens when we take that same logic that powers a virtual city in a game and we point it at a real one? The answer is a field that is completely changing how we tackle some of the world's most complex problems. We're talking about something called agent-based modeling, or ABM for short. This is the core tech that lets us build these incredibly powerful simulations of our world. It's almost like creating a digital twin that we can experiment with safely. So how does it actually work? Well, ABM builds these simulations from the bottom up. Instead of trying to write one giant messy equation for something as complicated as a city, you create thousands of individual agents. And these agents can be anything: digital people, cars, companies, you name it. You just give each agent a few simple rules to follow, and then you hit play. And here's where the magic happens. The results of all these simple rules interacting can be incredibly complex and, honestly, often super surprising. You get what's called emergent behavior. These are patterns that you never explicitly programmed in the first place. So what are people actually building with this powerful tech? The applications are just huge, and they're growing every single day. For example, urban planners can use it to test a new subway line and see exactly how it'll affect traffic and people's movements across the entire city, all before a single piece of track is laid. Or emergency services can simulate how a crowd might behave during a stadium evacuation to figure out the fastest, safest way to get everyone out. It's a game-changing tool being used everywhere, from economics to public health. This brings up a really fascinating question. Who are these new architects? Who are the people actually building these incredible synthetic environments? It's this super diverse group, which is what makes it so cool. And the really interesting part is the crossover of skills. You have game designers who are total experts at making believable characters, now working right alongside policy modelers and urban planners. It's this unique mix of creative and analytical talent that you need to build these realistic digital sandboxes for testing out big, real-world ideas. And this whole convergence is creating jobs that literally didn't exist a few years ago. We're now seeing titles like agent-based modeling expert, who's the person that specializes in the logic and analysis, and synthetic environment designer, whose job is to build the rich, detailed virtual worlds for these agents to live in. It's a whole new frontier of work, for sure. Okay, so if you're one of these new world builders, what do you actually use to build these virtual realities? Let's take a quick peek inside the toolbox that makes all of this possible. So the toolbox is huge and really specialized. On one side, you've got the big guns you might have heard of, like Unity and Unreal Engine, which are amazing for creating visually rich simulations with really complex AI. Then, for more academic or social science stuff, you've got platforms like NetLogo, which are designed specifically to model things like how a disease might spread. And for the really heavy-duty, large-scale research, there are dedicated platforms like Repast Symphony. The main thing to know is there isn't just one tool. There's a whole ecosystem, and you pick the right one for the problem you're trying to solve. Okay, so we've looked at what this stuff is, who builds it, and the tools they use, but let's pull back to the big picture here. Why is this so important? I mean, what does this actually mean for our future? The real power is in this four-step process. You start with really simple rules for individual agents. Then you let millions of them interact, and out of that chaos, these incredible large-scale patterns emerge. Patterns you could never, ever predict just by looking at the simple rules you started with. This gives us this unprecedented ability to test out ideas and see how potential futures might play out. And this right here, this is the key takeaway. These simulations are our virtual sandboxes. You want to see how a 4-day work week might affect an entire city's traffic, or how universal basic income could change a local economy? You can test it in the simulation first, see what works, see what breaks, all without any real-world risk. It's a completely revolutionary way to innovate and solve problems. So, that leaves us with a final massive question to think about. We now have the ability to build digital twins of our societies, our economies, our cities. If you had that power right at your fingertips, what would you simulate? What's the first global challenge you'd want to tackle? Now that's something worth pondering.